Okay, good morning, dears. Welcome to my lecture on Introduction to Machine Learning, and I am Professor G.C. Nandi. So, as you can see, we are living in a very critical situation. Global pandemic is there due to COVID-19 virus, and inter-campus is empty. So, under this situation, I was actually planning to conduct this lecture in a different way using Google Meet and other devices, directly recording and then sending it to you. But some of you requested to make this video lecture through YouTube, so that through YouTube we can see them, especially those who are living in a remote village, having bandwidth problem. For them, I am preparing this. Uh, and even then I was a little bit reluctant because lots of materials are available in the internet in this very important subject. But again, some of you actually told that giving an example, it was very convincing. So that's why I would like to tell you about that. Um, that our great epic Ramayana was written by Maharishi Valmiki. So she told that how many of us actually read from that book. Uh, Instead, there are so many translations in different languages uh, of which we follow because they are close to our heart and close to our dialect. And she told that we would like to um, see your version of machine learning. So that was a little bit convincing and encouraging. So I thought that I will do this. So let us enjoy and participate in the so that interactively we can learn this uh, very important and very interesting subject. So fasten your seatbelt and then let's start. Um, First of all, we are very fortunate that we are living in a society which is governed by AI revolution. Yes. Why it is called AI revolution? Because drastically AI, machine learning, deep learning, they are transforming the society uh, uh, towards the betterment. Okay, so this is called fourth industrial revolution. Okay, see, you see, industrial revolution. Why it is revolution? I told that disruptive changes are taking place every now and then, um, thanks to AI and machine learning, deep learning, right? With your mobile phone, you could just using Google Translator, you can speak to a person who does not know your language, English to Chinese, English to Hindi, Hindi to Chinese, all kind of things today possible. Amazing. It was unthinkable earlier in real-time translation. Then uh, image and video processing. Then so many other activity, fraud, financial fraud checking, all kind of things which we'll discuss in detail are happening now and making our society a better place um, every now and then. And that's why it is a revolution. There are, I would like to just tell you the relation between these two. I think that is the best way I can just depict. Say this is superset is artificial intelligence, and now machine learning is almost its child is almost engulfed of the set, and then slowly but steadily it's happening. Deep learning is the child of machine learning. So AI became the grandparent of deep learning, machine learning being the uh, um, parents of deep learning. This kind of uh, schematic diagram will help you to understand who is where. Okay, and we'll discuss in detail. And you see, in the history, we have seen also many kind of revolution. Those are political revolution. The idea of many leaders, the aim perhaps were the same, that to bring changes in the society. But in doing so, many times history shows us that there are bloodshed, there are anarchy, uh, and at the end, perhaps they could not bring the changes they wanted. Uh, but industrial revolution, on the contrary, if you see, they brought the engineers, scientists, they worked together and they brought silently the revolution and changing the society very silently to the betterment, right? So that's a little bit difference between these two kind of revolution. So we are talking about fourth industrial revolution, which is, which is actually fueled by this AI, machine learning, deep learning, and with the availability of suitable ecosystem like huge and very cheap storage today are available. Okay, and high performance computing facilities are available, and internet connectivity is there where you can just have an access to those storage devices thanks to cloud, and you can compute, you can develop the algorithm for um, tanking out your desired output. So perhaps this ecosystem is helping scientists to develop newer model, which very exciting and which we'll discuss. Not only that, they are also helping other very promising fields like robotics. Today, you see, we have in our lab a cobot, cooperative robot called OnGul, right? And we are using it for understanding the intelligent grasping techniques, you see, which is essentially inherently based on learning. For us, think about a kid, uh, they are having poor grasping skill. That's why parents are reluctant to give sophisticated item to their children for grasping, okay, because they can spoil or break it. But over the years, the same individual learns how to grasp, and they can very effectively, when grows up, then they can effectively grasp various sophisticated objects. So we are trying to understand this learning mechanism through our experiment using AI. Okay, this is another robot available in our lab. This is called Now Robot. A fleet of Now robots are available, and they have the promise. Means exactly this Now robot may not be, but this kind of robot has a promise to enter to your household as a personal robot, and they can help you in various daily to daily works. Okay, then you can think of Internet of Things. Today, smart home is a possibility where if you have devices like uh, mm, smart television, smart refrigerator, smart air conditioner, smart um, washing machine. Smart means they are connected to the internet through some smart chip. Okay, and then you can control them using your mobile phone. For example, before and surveillance camera also you can control them. And before coming to your home from the workplace, just 1 hour before, you can just switch on the air conditioner so that when by the time you reach, you have comfortable temperature uh, inside your house. Nanotechnology is another area, amazing field where using, you see, the atom molecule, you can create a structure, and the structure can help you in various ways. For example, in delivering drug in a targeted way to a place where it is needed. Okay, so all kind of exciting things are happening and changing our daily lives. Okay, now uh, let us also try to understand the some history, who actually initiated and who contributed. Knowing them is very, very important. So I will now spend a little bit time in um, discussing the timeline of AI. All started, this is a great personality in the area of computer science. You know, this Alan Turing. is a great British mathematician and computer scientist. He's the father of computer science. He in 1943 envisioned that if some machine ought to be called intelligent, then they will have to pass some test, which is called Turing test. Unlike others, he did not talk about what are the how a machine will be called intelligent machine, what are the characteristics they should have, but instead, concretely, he gave a bar which will test whether a machine is intelligent or not. Perhaps most of you know about this Turing test, but nevertheless, it is good to just recapitulate. I will try to explain in short what it is. You see, it is also known as imitation game. Okay, so the game is like this. So this is an interrogator. It asks question. Okay, fire queries. Okay. And these are there are two different rooms where in one room one man is sitting and another room woman is sitting. This interrogator doesn't know in which room who is there. Okay, and the game rule is like this. So interrogator will communicate and they will also communicate through some media. Okay, of course this type of computer are schematic, right? They were not available during 1943, but anyway there are some device for communication, right? Now interrogator will fire query and man will try to deceive interrogator, posing that he is a woman. And on the other hand, women also will try to convince that no, I am a woman sitting in this room. And then the interrogator will have to predict in which room who is there. Where is man? In which room man? In which room woman? And say uh, total number of prediction it did P, and total number of correct prediction which interrogator did is C. Then wrong or that person could deceive the interrogator P minus C times, because this is the wrong prediction which interrogator did, right? And using intelligence, both of them are trying to deceive this interrogator. Now, instead of a man, suppose in the room there is a computer now, or any machine whose intelligence we are testing. Other rules of the game remain the same. That means the interrogator doesn't know that man has been replaced by a machine. The machine is actually interacting the same way as man was doing. So suppose there are again, so it was trying to pose that it is C and C is trying to um, uh, reinforce. So no, it is I am C. So and this guy is actually deceived. Say total number of prediction again is P and total number of correct prediction is C dashed. Then total number of times where this machine can deceive this interrogator is P minus C prime. Now if at least P minus C is equals to P minus C prime, then we can call it can be more. It's good that if the machine deceive this interrogator many more times, but at least if it can deceive the same number of times as man deceived, then it passed the test. We'll call the machine pass the Turing test. Okay, so this is a small, very elegant method of testing whether a machine is intelligent or not, whether it is exhibiting intelligent behavior or not. Now, I know some of you uh, are intending to ask me that, sir, is there any machine as on date who has passed Turing test? Hold on, we are going to discuss that in subsequent slides. Okay, but before that, we should know about another contribution this great guy did in July 1942. Alan Turing developed a complex code breaking technique which he named actually Turingary. Now, this was only revealed in 1970s because this was a secret code breaking project. Now, if you see the background, the entire world was in war, World War II, right? In one side, German, Italy, Japan were there. Other side, other US, France, UK, all other countries were there, and they are fighting. And then German actually initially were vigorously making progress. So France they invaded, and then UK was their target. During that time, the situation of the war was very bad for UK, and then they formed a mission headed by Alan Turing, whose job is to actually decipher the code of German um, army. So what they were making, they were communicating through a code uh, about detail of their plan. Okay, so Germans were communicating using the codified message, right? And the code was sufficiently big enough and complex one to break in real time. Real time means suppose the code carries all the information that where to bomb, how much damage to be done, all kind of detailed strategic plan were there in the code. And if you break the code within 2 3 days, then it is meaningless because already the plan has been executed. So it was a really challenging thing to break the code, and because there are rudimentary computer kind of thing, no? So Enigma machine were there, and then it was kind of electromechanical computing machine. Even using those type of primitive machine, Alan Turing, perhaps for the first time, used AI technique. What is that? What was the technique? He gathered a lot of previous such code or data. Okay, and then he observed that at the beginning, at the end, uh, codes are similar. Then he tried to first break those code. Okay, and then amazingly he figured out that those codes are talking about good morning, there's good morning, what is the weather, all kind of rubbish, right? And the end also they are telling goodbye, see you tomorrow, all kind of things. So they intelligently tried to hide actual plan in between. And Alan Turing, through pattern matching, this is pattern matching, right? So similarity could understand these are useless. So he clipped the code. Now code got shortened. Okay, length of the code got minimized, and he could break the code. But he could not tell any others at that time. It was a secret strategy, and that history says that by doing that, using AI to breaking the code, Alan Turing could save millions of lives, and at least he shortened the World War by 5 years. Can you believe the contribution this guy had in AI? So I thought that I must tell you about Turing Eddy. And in the other part of the world, many things were happening. People were envisioning that one day we will be having intelligent machine. In 1950s, I wrote a science fiction short story book was published by Isaac Asimov, a great um, visionary. Then in 1956, John McCarthy in Stanford University, professor of Stanford University, he first coined the term artificial intelligence and propagated the idea of a pre-programmed rule-based expert system using a top-down approach. So we'll talk more about what top-down approach is, but basically what he wanted to do, he wanted to develop a strong AI system. Strong means a universal AI system which will behave intelligently and solve many real world problem, and many such tools and techniques were developed. See, one we learned about mean sense analysis, right? You have start, you have goal, maybe 50 is a start and goal, and you are taking action so that distance between them are decreasing towards zero. That means you are achieving the goal. So all kind of fantastic idea uh, were developed, and he tried to develop a detailed plan base from top down, that is top down approach, that everything should be planned a priori, and um, try to develop intelligent um, devices using that concept. Then in 1969, again in Stanford Research Institute, Seki robot was developed, which was a general purpose mobile robot, and which could take decision of its own actions by reasoning about its surroundings. It had a lot of sensors collecting data from the surroundings and taking its own decision. That was in that time with very primitive computing devices. It was really a breakthrough. Uh, Interestingly, the Seki robot name came from the fact that every time the robot started for moving, it shakes itself. So the designer or the team, somebody from the team, they gave the name Seki. Okay, so that was another breakthrough. But unfortunately, in 1973, AI winter began. Means uh, both funding agencies, government and private funding agencies, they poured millions of dollars in funding um, by getting tremendous encouragement by the scientists and the um, researcher in this area that something will come up, something great will come up. But unfortunately, um, the ecosystem at that time was such that no great thing which could change the society abruptly could take place. So all of a sudden, funding dried up. Means both the government and private agencies, they thought artificial intelligence is of no use, and many people abandon that field and try to go to a greener pasture. All kind of things happen. That's a very bad time. But again, in 1981, there was some changes of thinking. It's the same expert system which John McCarthy was trying to develop. Now was developed, but using a different concept. This time, it was narrow AI, not the or weak AI, not universal AI or strong AI. The concept is try to develop an expert system in a very narrow domain, and that created good result. You see, number of expert system came into existence. One of them is mycin, which is very good in medical diagnosis. Okay, so it could predict kind of disease, seeing the symptoms. Okay, it's a rule-based expert system. Again, another expert system which became popular is Dendral. Okay, which could actually um, do chemical analysis. So those were domain-specific expert system which got success. Then again in 1990s, a neural network actually which tried to emulate human brain were successfully able to do many classification tasks using bottom-up approach. So we talk about top-down, now it is bottom-up. What they are, we will try to um, discuss them afterwards. But what happened, you see, neuron as a computing device is not new. Even you, as you know, okay, in um, even in 19, I think 43, Pitts and Maculo, right? Pitts and Maculo develop simple neuron um, being vaguely inspired by human brain. Okay, and then Frank Rosenblatt in 1958 developed perceptron. But since computation power were not there, they were confined to classify only linearly separable problems because networking could not be done. But in 1990s, networking were done, and neural net could actually solve many non-linearly separable problems. So that was a sensation again, using bottom-up approach. The network the way we learn, we're allowed to learn from data from the in a reactive way, layer by layer. Okay, it's a bottom-up approach, using bottom-up approach. That was again a success. And in 1997, Deep Blue, which is a supercomputer developed by IBM, it defeated world champion chess player Garry Kasparov. That was another milestone of AI when it happened actually. So Deep Blue um, took the architecture of Deep Blue program um, were developed in a hybrid, using hybrid approach, both uh, top-down and bottom-up approach, and that was again a success. Okay, so all these things are the important milestone of artificial intelligence, and we'll continue till today what is happening in this field. But before that, I would, as I promised, I would like to just give an example to clarify your concept about the top-down and bottom-up approach. See, I will give an example. Suppose first time when you are coming to Triple IT campus. It is located in Jhalwa, Allahabad, as you know. But you may be traveling from different part of India, say southern part of India. So what you did, first you, after getting chance, after fixing the date, you planned your journey, detailed plan. That means I will start my journey by this time. I will go fast from here to the nearest railway station. Then I will catch this train, and then I will land Allahabad station, and then I will um, take cab, and then I will go to the campus, and then I will do this or that so that I will reach to my uh, room, okay, hostel room. Say you are seeing a map, you did this plan. So this is called top-down approach. So everything is planned, how to reach to my uh, destination, hostel room. Okay, even that minutely you planned. But suppose after landing to Allahabad station, you saw that due to Kumbh Mela, there are millions of peoples, and then total anarchy, you are not getting cab, you are um, some routes are actually blocked and you will have to detour. So then what will happen? You will have to interact with the environment and figure out what are the other alternatives, and taking those alternatives, you may reach to the campus and see, again interact. This is actually interaction means learning from data. So this approach, reactive approach of interacting with the environment and acting to achieve my goal is called bottom-up approach. So hybridization of these two approach actually are very beneficial, because some plan are to be there, but the plan should be allowed to have some flexibility, so that in a unknown situation some learning could take place, so that you can explore or go to the goal point, right? So this is actually in non-technical way I try to um, clearly tell you what top-down approach and what bottom-up approach is. Both are good in their own field. Hybridization is the best one. So with this, we'll continue our timeline of AI in my next class. Till then, stay safe, take care, bye-bye.